like to welcome you to our digital classroom brought to you by HD Supply. I'm Jerry Winslet, along with Jason Leonard.
Hey, everybody.
And today what we're going to be talking about is gas water heaters. Particularly, we're going to talk about troubleshooting gas water heaters. But before we start, I just want to tell you a few things. If you have questions about anything we're covering here today, you can use the chat feature, which is on the right-hand side of your screen, on the other side of Jason over there. Just type in your question. We're going to have a question and answer session at the end of the program. You know, you don't have to wait till the end of the program. You can do it anytime during the show. Also, we've got something new. We've got a couple of things that are down below the screen here. We've got a couple of PDFs that you can download. And it's really cool because what you can do with these PDFs is you can follow along with us as we go through the troubleshooting. We've got step-by-step instructions on what we're going to be covering today. So you can download this, follow along with us. You can use it whenever you go out to the job site. It's all detailed out.
Yeah, it's a great resource. I mean, you print these out, keep them with you. You can watch the show, learn everything that we're going to tell you to do, but you may forget some of these small little details. Print this guy off, keep this with you. Keep it in your service truck, keep it in your office, keep it wherever you need to. And if you run into one of these issues, you've always got this with you, step-by-step process how to resolve those issues. Yeah,
and there's also, at the bottom of that PDF, there's also the website where you can go to where you're at right now. You can always go to that the website, and we've got a number of different videos on that website. But let's go ahead and talk about gas water heaters and troubleshooting. But first, you know, we've got, you know, a gas water heater. We've made a couple changes over the past couple of years on how they operate. And really, we've got a couple different gas valves up here. Let's talk about the gas valves and what kind of sets them apart. Yeah. First off, they're different looking. I know that.
They are, and depending on, you know, the year of the heater that you're working on, you're going to see one of these two styles. This is the mechanical version. This is the electronic version, of course. This change kind of happened for us around 2010, 2011.
Right.
So if you're looking on a heater about that age, that's where you're going to start to see this transition between the mechanical and the electronic. We'll start out with the electronic and just look at some of the differences. If we can get an overhead, we can kind of see one of the big differences you're going to notice is the temperature probe that sticks into the water heater.
Right.
These are the temperature probes here. This is our mechanical style. Here's our electronic. This is the part that actually reads the water temperature.
Okay.
You can kind of think of this in terms of digital and analog, right? The older style was more analog. Wasn't quite as accurate as, of course, the digital style. What we're looking at here, this is your old rod and tube style temperature probe is what it's referred to as. This one's a little bit shorter, you'll notice. That's because the only thing inside here is a thermistor. Again, we're taking this temperature electronically. That allows us to get a little bit more accurate in that water temperature.
So this is our digital. This is what's
this is our
so
digital.
we're being able to get more accurate temperature readings on this one.
That's
as
exactly right.
This one.
It runs a thermistor. A thermistor you can actually get to about 1/10 of a degree.
Oh, really?
Now this one's what's referred to as a Drywell Thermistor, which means the thermistor itself doesn't actually contact the water. It's housed inside this housing. But that allows us to get about a 2-degree differential on temperature. So we're definitely getting very accurate in terms of temperature control. Where this one, the parameter is a little bit wider because, again, it's an analog style. So you just can't get that accurate with those.
Okay, and another thing too, I noticed that we had 2 knobs on this control, and we just went to 1 knob with the electronic.
Yeah, that's the other difference. On this one here, you'll see that this one has 1 knob, and this knob kind of does our off or on or pilot, everything. You may see this one with a red knob also. There may be 2 knobs on top. There could be a red one here that would be your pilot purge.
Okay.
This one just happens to have all of those incorporated into one. So you may see either one of those 2 styles.
Okay.
On the electronic, you see that everything is right here on the front of the dial. Here we have our temperature control on the mechanical style and our pilot and our off and on. Everything here on the electronic is housed inside this one switch.
Okay.
All right, this one dial. We can push in on this. This gives our pilot purge. Then we turn it to on, and then of course at our temperature control, everything's done with this one dial instead of multiple dials.
Okay.
A little bit easier for the end user as well if they need to make adjustments and those things, or relight a pilot or something like that. Just a little bit easier for them.
And another thing too that has changed is with the newer style, we're able to have status codes, which is different because with the older style, we weren't able to do that. Let's talk about the status codes and what they mean, really.
Yeah, that's really the big deal with the electronic gas valve. Because it is electronic, now it has the ability to communicate with you a little bit. If we have an issue with the valve, with the mechanical style, there was no way to know. Without physically going in, running some diagnostic tests, seeing some numbers, that would tell you what was going on with it. This valve actually has the capabilities of doing its own diagnostic testing. There's a board on the inside that's monitoring the control. And if it sees a failure or a fault or something like that, it can actually throw a flash code. If we can look at the front of the valve, we can see that there's a status light right there. Now what's going to happen is that status light will blink. In a normal operation, it's going to blink as well. It gives what we refer to as the heartbeat flash. That just lets you know that everything's fine. If it goes into a status code, then you're going to see a different series of lights. Say an error code 2 is going to give you a 2 flash and then a 3-second pause. 2 flash, 3-second pause. But again, the valve is a lot smarter, can communicate with you a little bit. So if we have some of these internal failures or something, the valve can tell you that without you having to do the test on your own.
Right, and one of the things about the code, though, the only way you can have a code is if you have a pilot.
That's exactly right.
Because, you know, we don't plug these water heaters in, and we have to generate enough electricity to run that, the gas valve. So let's talk about how we run the differences between this water heater and the older mechanical style, how we're generating that power.
Sure. As you stated, we don't plug this water heater in, right? Traditionally, atmospherically vented water heaters do not need any type of wall outlet or anything like that. Now, once you go to an electronic control, then of course we're going to have a little bit more power. If we're going to run things like status lights, those type of things, then we're going to have more power than the old mechanical style. Now, as we stated, they don't plug into the wall, so they need their own internal power source. Now, for decades, that's been done with what's called a thermocouple, right? On a mechanical style gas valve, and we have one right here. This is just a standard Honeywell 24-inch thermocouple. This was the standard for decades and decades and decades. This is what ran the older mechanical style valve. Now, the way this thing works, if we can go to an overhead, this area on the end here, this is the area that would sit inside the pilot flame. So once we get the pilot lit, this is going to be sitting inside the pilot. The other end that we see here, this is the end that attaches to the gas valve itself. So we get some power generated from the tip of this. We're basically turning that heat energy into electric energy. That gets converted throughout the length of the thermocouple. So that pilot is going to start to heat up this tip, produce millivolts. Now millivolts is of course not a lot of power, right? But it is enough to run the valve, and that gets distributed from the thermocouple into the valve on this tip right here. Now, as we stated, the electronic valve is going to need a lot more power. These will traditionally produce anywhere from about 10 to 30 millivolts. 30 is about the max you're pretty much going to see out of one of these. But 10 is what you're looking for. Now, that is not enough to run an electronic gas valve. You're going to have a little bit more power. And what we're going to use is this right here. This is what is called a thermal pile. Get this opened up where you can get a good look at it here. The thing is they work identical. There's nothing magical about it, right? This area here sits inside the pilot. This starts to heat up and produce our power. That gets transmitted through the gas valve through this wiring connector right here that plugs into the front of the electronic control. Again, it works identical to the older thermocouple. We call it a thermal pile, and if you think about that name, it's actually a pile of thermocouples. If I can get a little bit of power out of one thermocouple, then I can get more power out of a bundle of thermocouples. And that's basically what this is a bundle of thermocouples in one housing. We heat up this tip, we can produce a whole lot more power. Most of the time, you're going to see anywhere between 350 up to maybe 900 millivolts.
Right, depending
out
on
of
how
a
old
standard
it is,
thermal pile.
probably.
Yeah, that's going to drop a little bit as you point out as age as it goes on, but 350 is what we need to run the valve. But it'll run anywhere from 350 upwards of 900.
Yeah, so 350 is a number that you want to remember whenever you're doing any kind of troubleshooting. We're going to get to that when we get to doing troubleshooting.
We will. When we touch on troubleshooting, we're going to talk about those numbers. And again, as we pointed out earlier, you have that PDF there. All these numbers are going to be on that PDF. We encourage you to print that out, keep that. It's a great resource.
Yeah, and I mean, this is we were just going to talk a little bit about, you know, the differences. This is what we're really going to get into now. We're going to talk about the troubleshooting. And really, again, you can follow along using these PDFs, which is on right below the screen, or the window in the on the website. Just right below that, there's two links that you can get, two PDFs. There we go, right there. There they are right there. You can go ahead and download those PDFs. I can go ahead and press one, show you what it looks like.
Yeah, there we go.
That's what you'll get if you press on that link. Then that's where we're at right now. We're going to talk about the mechanical style troubleshooting, and specifically, really, when you look at it, we've got a call center here, so we know what's going on in the field, and the number one call really is no hot water. Is what you usually get, and it happens on install, and it can happen over time. But it's no hot water. That means that they have no hot water come from the water heater. So the first thing they're going to want to do is to make sure that it is the water heater. So they're going to want to have to go to you know, all the faucets, make sure that it is coming from the water heater. But once we do that, you know, let's talk about troubleshooting. We're going to use a base actually.
We've got a couple of bases here. First thing we're going to look at is the mechanical style. And all this is just the bottom of a standard water heater. This lets us open this thing up so you guys can get a look at what's going on the inside as we perform these tests and those type of things. Just gives you a little bit better view. And as you pointed out, traditionally the number one call you're going to get is no hot water.
Right.
Now there could be a lot of reasons as to why they have no hot water. But typically all the end user is going to say is, hey, I don't have any hot water. So when we go out there, what do we do? When there's no hot water call, what do I do when I first show up on the job? And
that's what we're going to cover today. The steps you need to look at when you're faced with a no hot water call. I mean, we're really going to just kind of break it down into two different roads that they can take. So let's go ahead and say we're coming out to a house. We've verified that we have no hot water, and it's the water heater. So what's the first thing we're going to do when we come to the house?
Okay, the first thing you want to do is verify whether or not the pilot is lit or not. We know it's a no hot water call, right? So we assume that the water heater itself is not producing any hot water. And as Jerry pointed out, we're going to have them make sure that that's all over.
Okay.
It's not in just one specific location, but if there's no hot water in the entire home or apartment or whatever it is that you're looking at, then we know we have an issue. The first thing you want to do is make sure that you have a pilot lit. You're going to have to look inside this little small inspection window and look and see if that pilot is present. Now, sometimes this can be difficult. You guys know how it is. You get out to an apartment complex, you go inside the unit, you open up the closet door, there's the water heater, but what else is there?
Yeah, everything else in
winter
the house
coats and Christmas trees and, you know.
It's where they pack everything.
Yeah, exactly. Everything else is around that water heater. And it's going to be all the way down at the bottom. You know, sometimes it is a little bit difficult. You got to get down on your belly a little bit and look inside this little light. But what we're looking for is just a clear blue light. A lot of people think, well, if I'm looking for a pilot, I expect to see this big, large flame on the inside of the water heater. 10 years ago, that was true. But as energy efficiency has become the norm in water heaters, that pilot has been reduced over the years. Again, that thing's burning 24 hours a day, 7 days a week inside the bottom of the water heater. So the smaller you can make that pilot, the more energy savings you can get. So all you're going to be looking for is what looks like a clear LED light. On your PDF there's a picture of that, so you can kind of see what you're going to be looking for. And it could be to the far left or far right when you look inside this viewing window. There we go. There's a shot right there. There's your pilot that you're looking for. That's typically what you're going to see.
And you may need to, like it says in the PDF, you may need to dim the room lights because it may be kind of hard to see, especially if there's a lot of light in the room.
It is. Sometimes if there's a lot, keep in mind it's dark inside here, right? Because this is underneath the water heater normally. So if there's a lot of light in the room, this little glass has a tendency to kind of act like a mirror.
Yeah, so
Right?
yeah,
So
yeah.
you get in there and you got a flashlight in your mouth and you're standing on your head and you're trying to look inside this thing and you look inside the glass and you don't see anything but your own eyeball,
Yeah.
right? Because it's just acting as a mirror. So turning those lights down in the room will let you see inside the heater a lot easier.
Okay, so once we do that, we've verified that the pilot's out. The first thing that you're going to want to do is we're going to try to relight the pilot.
Yeah, if there's no pilot, that's the first thing we want to do is go ahead and relight that pilot.
Yeah, follow the lighting instructions that are on the water heater. They're going to tell you step by step how to do that. Now, once you try to do that, this is the thing that you run into. I'm trying to relight the pilot. I can't get the pilot to light.
Yeah,
where do I go from there?
That's usually what happens. What we're going to have to do is, of course, we're going to turn our gas control valve to the pilot lighting position, right? And we're going to have to push down on that pilot knob, right? Now, when we push this down, now we're letting gas flow through that pilot tube out to the pilot orifice.
Right.
Now, the next thing we're going to have to do is click off our igniter, right? While we're holding down that pilot knob, we're going to have to hit this igniter button. Now, if you can get a close-up, let's see if we can get a close-up right there on the igniter and see if we can catch this spark.
Yeah, I think you can see.
You can see it a little
Yeah,
bit.
because you're either going to light it or you're not going to light it whenever we're trying to light this.
It's difficult to see, but that's what we're looking for on a mechanical style. Now, once we hold down our pilot knob, we start purging, and you notice, if we can get another close-up there, we can see that our pilot is lit. Let's see, the pilot is lit now. Now, if you can't get it to light, if it will not light at all.
Yeah. What if I'm trying to do this and I can't see the pilot, it's not lighting? Where do I go from there?
If we're getting spark, again, we have to verify that we are getting spark. If we're getting spark and that pilot will not light, chances are this is going to be a gas issue.
Yes.
There's something on the fuel side of this equation that is off. It could be that maybe the main gas line is off.
Right.
The main shutoff to the water heater may be off. So you may want to look for that.
So it's something upstream of the gas water heater. I mean, it could be a shut-off valve. It could be it's something upstream. So you're going to want to verify that you got gas going to it and do those steps before you move on. But
especially if it's a new install.
Right.
If it's a new install, you may have to purge that gas line
Yes.
before it's going to light. On the new install, that gas line is going to be completely full of air, right? So we're going to have to purge that air out of the way
Right.
And get that fuel up to the pilot orifice before we ever get that pilot to light. So if it's a new install, keep that in mind. We're going to have to purge that gas line.
yeah, so it's something on the gas road. So you take the gas road. So if you can't light the pilot, when you're trying to relight that pilot and you've got a good spark, you're going to have to take a look at that gas side. But let's say we go ahead and light the pilot. It does light. Now this could take up to like 60 seconds or so for that thermocouple to heat up enough to generate enough electricity to hold it open.
Yeah, let's say we go through those steps. We actually get a pilot to light.
Right.
But it's going out as soon as we let go of the pilot knob. Okay, first of all, we want to make sure that we're holding it down long enough.
Exactly.
Typically, on a mechanical style, it's going to take 1 full minute, at least 1 full minute of that pilot being lit before that thermocouple produces enough energy to hold the valve open. So you have to make sure you're holding it down for at least 1 full minute. Now, if you're doing that, if we're holding it down for 1 full minute and it still goes out as soon as we release the knob, we refer to this as pilot will not hold. On your PDF, you're going to see that as a title, pilot will not hold. Now, the first thing that you're going to want to do is check your reset switch.
Okay, so that's electrical side. That means that the electrical signal's not getting back to our gas valve.
That's exactly right. If you have no pilot at all, it's on the gas side. If you do have a pilot but it goes out, it's on the electrical side.
Okay, all right. So the first thing we'll do is we're going to check our door switch. Now, that the voltage coming from the thermocouple is actually running through that door switch.
That's right. There's a circuit that comes through the thermocouple, out through that door switch, and then back up to the gas valve. So that safety switch is there. It's measuring the combustion temperatures inside the chamber. So if they become too hot, this switch is designed to open up and break continuity on that circuit, right? So if it opens up, now we no longer get voltage coming through there. So the thermocouple may be producing voltage, but if that switch is open, that voltage never gets back to the gas valve, so it won't hold it open. So that's where you want to start, is check this switch. Now, if we can get a close-up on that, we see that there is a little bit of a, see the little
You can see the little button in the
Yeah,
middle.
a little button right there in the center. That's what we're after. We're just going to push in on that button. Typically what you're going to hear is a little small click. You're probably going to feel it as well. Depending on the noise level where you're at, you may not hear it because it's not really loud. But you may hear a little small click, and you should feel a little small click. If that happens, then you know it was tripped and now it's been reset.
Okay, but let's go ahead and say, for for our purposes, let's say we try to relight it, and we're holding it down, and we release it, and it goes out, and I press the reset button, and it didn't click. Where am I going with that? I mean, the thermal switch never tripped. Now where am I going?
Yeah, if the thermal switch was not tripped and it's still going out as soon as we let go of that knob, the next thing I'd want to do is what kind of voltage are we getting out of this thermocouple?
Okay.
We know that thermocouple has to produce voltage in order to hold the valve open. It takes at least 10 millivolts to do that. So the next thing I want to verify is that thermocouple producing the 10 millivolts I need to hold the valve open.
Okay.
We'll show you on.
Take this, set that over there.
Yeah, I think we're done with this.
Yeah,
aren't we?
we are.
We'll just get this one out of the way.
Yeah,
We'll
so
show
we'll have
you
to
on
have
the
the right
standard-
test equipment as well for this.
Yeah, we're going to show you here on this this standard thermocouple what we're after here, and we're just going to take a digital multimeter. This is one that we picked up our friends at HD Supply. They can hook you up with anything you need to do these tests, and it's just basic hand tools.
Yes.
It really is. There's nothing hard
Yeah,
about
with
it.
dealing with these, you need basic hand tools, a multimeter, and a manometer. Digital manometer is very important when we're dealing with gas.
Yeah, absolutely. Those are going to be the main test equipment that you're going to need to run any diagnostic tests. And again, the folks at HD Supply can hook you up with whatever you need to do those tests. This is our thermocouple that came out of the mechanical style valve that we were looking at before. And all we're going to do is we're going to take our multimeter, we're going to turn it to voltage. Okay, and what we're looking for is DC millivolts. Now this meter is auto ranging from AC to DC, so we don't have to worry about anything there. It'll automatically set that for us. Really great meter. And all we're going to do is while we're holding down that pilot.
Yeah, so we have to hold down the pilot when we're doing
Correct.
this.
The pilot has to be held down. And what we're going to do is we're going to take our leads and we're going to put one lead to the very tip of the thermocouple and another lead to the body of the thermocouple, anywhere on this copper tube where it sticks out right there in front of the water heater.
Okay.
Now, as long as this end is in the pilot flame, right, and we're going to have to hold down that pilot knob, then we should see the voltage that's being produced by the thermocouple.
Right.
And again, the number we're looking for here is 10 millivolts. Anything above 10 millivolts, you're fine, that's a good thermocouple. Again, you may see anywhere between 10 to 30. If you get 17, 27, all that's fine. If you're not getting 10, if the number is below 10, then your thermocouple is bad and it needs to be replaced. This will happen from time to time.
Okay. Yeah.
It takes a while.
Right.
Honeywell says the average lifespan is about 100,000 hours. If you do the math, it's about every 10 years. We used to get out of the truck in the old days with one of these in your back pocket because you knew that's what it was. Eventually every 10 years you're going to run around and replace thermocouples in the heaters. So you just hop out of the truck with one of these in your pocket because you pretty much knew that's what the case was.
And it's a good idea with this test is to have some alligator clips on the end of your meter because you will have to hold down. The most important part of that test is holding down that pilot.
It does make it a lot easier if you have the alligator clips that go onto the end. I know you guys can't see this, but the end of these things are threaded here. So that you can screw an alligator clip onto these.
Right.
Makes it a lot easier, unless you have an arm growing right out of the middle of your chest.
Or a helper.
Or a helper. You may need a helper. If you need a helper, I'll send Jerry out.
I knew you were going to say that. Yeah.
So, you may have to have something else. A clamp sometimes comes in handy if you got a clamp to hold down the pilot for you while you perform this test.
Yeah, we just need to make sure that you have a pilot whenever you do this test because that's the only way you're going to generate the millivolts.
That's exactly right.
Okay, so that's testing that. So if we have below 10 millivolts, we're looking at the thermocouple. You need to replace the thermocouple. Now, if you have above 10 millivolts, if if you have below 10 millivolts, but if you have above 10 millivolts, it'll be the gas valve.
That's right. If you're still having
I
that
got
same
confused.
issue,
Sorry about that.
you're still having that same issue. You're holding down that pilot knob, and it goes out as soon as you release it. The door switch is not tripped, and you're producing above 10 millivolts on the thermocouple, then it would be your gas valve. It's pretty rare for a gas valve to fail. They're fairly bulletproof. Not to say it doesn't happen. But that's when you would want to look at the gas valve. Door switch is not tripped. I'm producing more than 10 millivolts on the thermocouple. Then I would look at changing that gas valve.
Yeah, and you would do that test if your pilot didn't hold and your thermal switch didn't trip.
That's right.
But if your thermal switch did trip, and you had to go there, your pilot won't hold, you release the knob and you press that button and it does click, and then now you can relight the pilot. You know, you don't want to just push that button and walk away.
That's right.
You know, what's my causes for that thing to trip?
Yeah, if we're tripping that door switch, again, this is a safety switch. It means for whatever reason, the temperature inside that combustion chamber is getting way too hot. It trips at about 410 degrees Fahrenheit on the door switch. Now, that is all the way outside on the door below the burner. So that should be the coolest area of the combustion chamber. If that area is getting too hot, that's a dead giveaway that we have an airflow issue.
Right.
Something is restricting the airflow into the bottom of the water heater. Now, this could be a clogged up air filter at the bottom of the water heater. Typically, there's going to be a wraparound air filter there. If this water heater is installed, especially in like a laundry room, what else comes in a laundry room, right?
Yeah,
you got
lint.
a dryer, you got lint, dust bunnies, all this kind of stuff. It may get sucked up onto that filter at the bottom of the water heater. If that gets clogged up, we're going to restrict that airflow. That's going to cause that chamber to overheat. Also, we talked about a lot of times these water heaters in their closet, and again, there's Christmas trees and winter coats and everything else in that closet as well. And maybe that closet door is not cut properly. A lot of times they leave a little bit at the bottom. They'll cut it high over a high pile carpet and leave a little bit of gap. Well, sometimes carpet gets replaced, right? Maybe the new carpet's a little bit taller and it closed up that gap. It may be choking the heater down.
Right.
It's a good idea to have louvered doors on that closet, again, to give that closet enough air. We have to supply that heater with enough makeup air.
Yes.
If that door switch is tripping, then we know we've got an airflow problem, either air in or air out.
Okay, all right. Well, that's the mechanical side. What we're going to do now is we're going to talk about the electronic gas valve, which is a little bit different in the steps in troubleshooting, but it's pretty much, I mean, the thing works pretty much the same way, other than there's, you know, we've got lights now, so now we've got something else to look at that is going to help us out in troubleshooting. So if you want to go to the next PDF, we can follow along with us. If you have any questions, again, just use the chat feature, which is on the right-hand side of your screen. We'll get to those questions after we get done with this portion of the troubleshooting. So, all right, so let's do this again. You know, it's the same thing, no hot water. The first thing we're going to do on this is a little bit different. What are we doing when we come to the water
It is a
heater?
little bit different. Like we talked about earlier, because this valve is electronic, it has the ability to communicate with you a little bit. So we talked about earlier with the mechanical style, kind of get down on your